Today we are going to be doing a very fun science experiment. But before we do the experiment, we have to learn some things first, okay? So who can read to me exactly what we're going to be able to do by the end of this lesson? Wow, look at all my great volunteers. Oh, Audrey's sitting on our bottom. I'm going to call on her. Can you read that to me? Oh, that's a big word. Evidence, good. Okay, so we are going to be able to prove that the earth changes quickly and slowly. How are we going to do that? By doing an experiment. Fabulous. So last week we kind of learned a little bit about quick changes and slow changes that the earth can have. Raise your hand if you remember one of the quick changes that we learned about last week. Cadence. A flood, right, because that happens very quickly and it changes the earth very quickly. It doesn't take weeks or even years sometimes to change the earth. A flood is quick. It happens all of a sudden. Jasmine, what else? A hurricane is a quick change. Good. Clark.
A tsunami and a tornado.
Oh, a double tsunami
/ tornado.
Well, they're a little bit different. A tsunami is kind of like a tornado in the water,
I know.
right?
Oh,
I think we have one more room for one more, Nicholas.
It's an earthquake.
An earthquake is another one. Oh, thank you for listening, Bailey. I love how you didn't shout out during that. I have one more that I'm really thinking about. A quick change. Steve, what do you think?
Volcano.
A volcano, yes.
And an experiment.
A volcano. Guys, all of these events happen pretty quickly. What about some events that might happen slowly? Things that take a little bit more time to change the earth. Can you think of one, Addison?
Yeah, hills.
What do you mean hills? Like
when they go up, they move.
they move, right? So we could also call that,
But
I know what you're saying. I'm gonna come back to that, okay? Can you think of another slow change that we talked about, Colton?
water hitting rock.
Erosion, right? Erosion.
You have to think about what the.
Yeah, I was thinking about how to word it because there is a special word for it, but I'm just gonna say
We could put
exactly
it on
what
the
you
Google
said.
World.
Hills and land moving. Over time, like we talked about last week, you might notice a fence leaning over because the earth moves over time. Or you might notice roots of a tree coming out through the sidewalk
Just like Bobby.
because they grow and they move things, okay? Let's focus on this one today.
Yes.
A volcano. I want to know everything that you already know about volcanoes. What do you already know? It's okay if you just know that they explode. Tell me everything that you already know. Thomas, what's one thing you know about a volcano?
There's a hole in the middle where the lava comes up.
What's lava? Lava sounds like a vocabulary word. A volcano vocabulary word. Wow, that's a tongue twister.
Molten rock.
Volcano vocabulary word. Home and top. And you said lava. Good. Jonah, what else do you know about volcanoes?
Parts of the volcano come off the volcano side, and then the little rocks that come into the volcano makes more lava, and then that makes it erupt.
Okay, I love that word, erupts. And you said that rocks on the side kind of
Break off.
Rocks break off the side.
To
Good.
make more lava.
Good.
So can I have a later?
Nick, maybe I will call on you if you can show me. Riley.
Rocks burn to the ground.
They burn. So is a volcano hot or cold?
Hot. Actually, just right, a volcano is hot.
It's hot. Good. Hot. I'm gonna put burning. Right. we are going to come back to this, and we're going to write the things that we learned in a minute outside of our little volcano, okay? So we're going to watch
Moby and Max.
yes, a little brain pop
Read Annie
about
and
volcanoes.
It's the one that comes the lava through. Moby and Max.
All right, guys, while you are watching this video, what do you think you should be doing behavior-wise? Mitchell, tell me one thing you're going to do. Sitting down. What else are you going to be doing during this video? Clark, sitting down.
Hands on head, bubble in your mouth, and be quiet.
Wow, you don't have to put your hands on your head just because if Wyatt has his hands on his head, maybe the person behind him couldn't see. But I like your idea. Bubble in the mouth. We're not talking. We're facing the board, right? Voices are off. Let's see what we can learn about volcanoes afterwards, okay? And while we're watching, I want you to try to think of one new thing that you learned from this video that we can add to our chart, okay? Yes, I'm going to turn the lights on.
Dear Tim and Moby, what makes volcanoes erupt? From Dylan. That's a great question. Volcanoes are openings in the ground that release energy from deep
Teachers,
inside
please
the
pardon the
ground.
interruption. Just wanted to let you know that the pictures that Ms. Elstro brought around need to go home to the parent, and if they choose to purchase something, then they will return the money and the unused portrait or the entire package. So just as you get those in, send them up to the office. It is totally an optional program. If you have any questions, give us a call.
All right, sorry guys, I'm gonna start it over really quick because of our little interruption. Oh, how funny, an eruption, interruption, almost like a volcano erupting, huh? Okay, yes.
Ground that release energy from deep inside the planet. Sure, up here on the surface, the Earth seems pretty cool and stable. But miles below our feet, it's a raging inferno. The deeper you go, the hotter it gets. Earth's center, or core, is about as hot as the surface of the sun. All that energy wants to escape like steam inside a boiling kettle. It pushes outward, forcing material in the mantle toward the surface. Standing in the way is the crust, the planet's rocky outer layer. Yep, it's paper thin compared to the other layers, but we're still talking about miles of heavy rock. The rigid crust keeps the mantle material trapped below. But in some places, the mantle forms pockets of magma, molten rock mixed with hot gas. The liquid...
Okay, so guys, looking at this picture, this is the ground that we actually see. Underneath the ground that we see are lots of different layers. And very deep in the ground is this stuff right here called magma. Magma is like hot liquid and rock, and if it gets hot enough, something happens. Let's keep watching.
Magma is much less dense than the solid stuff all around it, so it begins rising. As it rises, the dissolved gases form bubbles that rush to escape, shooting the magma up even faster. Yeah, that's what happens with gas bubbles trapped in liquid. When the magma reaches the surface, it's called lava. Layers of hardened...
Okay, so magma and lava. They're kind of the same thing, but they're just called different things based on whether they're under the ground or out of the ground. So what is it called when it's in the ground, Amity? Magma, good. And then what is it called when it's out of the ground, Mitchell?
Lava.
Lava, fabulous.
Lava build up over time into the mountain-like formations we call volcanoes. Well, the type of formation depends on what's in the magma. Less gas means less pressure, making for gentler eruptions like Kilauea on the island of Hawaii. Streams of thin lava from these eruptions flow far before cooling, forming flat mountains with broad slopes, kind of like a warrior's shield. That's why they're...
Okay, so he's saying that sometimes volcanoes, they will shoot up and explode huge, but other times it might just kind of like trickle out, kind of like this. There's just a little bit flowing out, like a small stream or river. Well, yes, it is.
called shield volcanoes. Magma with a lot of gas can build up a tremendous amount of pressure. The result is an explosive eruption that can send out pyroclastic flows, super fast avalanches of hot ash and poisonous gas. Thick lava from these stratovolcanoes doesn't flow very far, so it piles up in steep slopes. Washington State's Mount St. Helens is one of these. It exploded in 1980, blowing most of its peak right off. And when Mount Pinatubo erupted in 1991, its ash clouds blocked out the sun's rays and lowered world temperatures for months. Well, fortunately, eruptions don't just happen anywhere. Magma only forms under special conditions, usually near the margins of tectonic plates.
Alright, so they're about to explain that. But guys, it's not like across the street on that hill is going to be a volcano one day, right? Magma is not under us right here. It's only under certain areas in the world. There are no volcanoes in Kentucky. It's actually a good thing, Emily. I know it'd be really cool to see one, but what do you think happens to the people and the animals that live on a volcano if it erupts? Jesse, what do you think happens?
They'll die because it came up on them.
Yeah, you do not want to be around a volcano, okay? I know it seems like it might be cool, but I promise it would not be very fun. Let's find out exactly. What is it, Jesse?
So are volcanoes like a bump in Earth?
Well, they're a mountain, but the magma is what makes it a volcano. If there's magma underneath the mountain, like we just saw, then it can become a volcano. And they're about to show you where all that magma is located. Because like I said, there's not magma right here that's going to blow up. Okay? Let's keep watching.
These are massive sections of the Earth's crust and upper mantle. The plates are in constant slow motion, pushing together, pulling apart, and sliding past each other. Mid-ocean ridges, where plates pull apart, are the most volcanically active boundaries on Earth. As the plates separate, pressure on the underlying mantle decreases, allowing it to melt. The liquid magma rises to fill the gap between plates, pushing them farther out. This goes on and on, continually adding material to the sea floor. Right, the Pacific Ring of Fire is another huge volcanic area. Its eruptions are fueled by collisions between ocean plates and continent.
Okay, so looking at this map, friends, we live right here. There, I'm gonna put that in blue because we don't have any volcanoes. All the little red triangles are where a lot of the volcanoes are. Do you notice that a lot of them are on the edges of countries? They're not gonna have a volcano right here in the middle of a country.
We're really close to a volcano.
We're not very close. There's some over in California. There's a couple in Alaska. And then there's quite a few in Hawaii, which is over here. So, let me erase that for you.
It looks like it's gone. Where's that place right here? With red in the circle where we were just that by.
That's us. That was us.
Is there some in Illinois?
No, there's none, guys. It's except for like on California and in Central America, South America. This is California. That area.
What about
Okay, in Washington, they said Washington State had Mount St. Helens in 1980 that blew up. A lot of people were hurt or killed in that volcano. No, there's none in Florida.
Did it just melt?
Are you guys ready to listen again?
Yes.
Cool plates. The ocean plate is denser, so it gets pushed under or subducted. Seawater leaks into the mantle, lowering its melting point and creating magma. So when the magma erupts, it's recycling some of that old ocean crust as new land on the continent. In fact, geologists believe that billions of years ago, the continents first grew out of the oceans from shield volcanoes fed by subduction.
Where is that?
That means eruptions are ultimately responsible for just about every bit of land in the world. Well, the Hawaiian shield volcano is a little different. It's an example of hotspot volcanism, which happens far away from plate boundaries. Geologists aren't sure whether these eruptions are caused by an unusually hot region of the mantle or an unusually weak region of crust. In any case, the near-constant lava flows on Hawaii's Big Island make it the only state in the country that's growing. Right. If you live near an active volcano, remember that eruptions can happen at any time and without much warning. So it's important for your family to be prepared, no matter how long it's been since the last eruption. You should put together disaster kits with things like food, water, and medicine, a battery-operated radio, a flashlight, and a mask or goggles. In the event of an actual eruption, follow instructions from local authorities. Don't worry, Moby. This volcano is dormant. That means it hasn't erupted for a long time. Of course, you never know with volcanoes. You, on the other hand, are more predictable.
Okay.
You're more predictable.
So, while you were watching, you should have thought of one more thing that you learned about volcanoes that we didn't know before we watched that video. What did you learn? Oh, I'm looking for somebody sitting on their bottom. I'm looking for somebody that was not talking during the video. Their hand is raised. Their eyes are on me. What did you learn, Cadence?
That the lava is as hot as the middle of the sun.
Good. Lava is as hot as the sun. Wow, that is hot.
That is.
What else did you learn? Nicholas.
I learned that the magma forms when water hits the underground, and what I was going to tell you was that once the lava gets to a certain point close to the bottom of the mountain, it cools and it turns into a black rock that stops the lava from flowing.
Wow, Nicholas learned a lot. I am so proud of your listening skills, right?
actually knew
So he's exactly right. When the magma and the lava hits the water, it cools and it creates a rock. So that's kind of how some of our land was formed. Because eventually when the volcano stops erupting, that's exactly how Hawaii, the whole island, was formed because of volcanoes. So Nicholas, I'm going to put over here that
since he wrote that the lava
cools into rock
or land.
/land. Exactly.
Learn that.
Awesome. Let's add a couple more things that we learned. Wyatt, what did you learn?
Just like what Nicholas said, it creates a rock constant that takes a long time to turn around.
Yeah, it takes a long time. So even though it is a quick change, it takes a long time for it to actually erupt. So once it erupts, then it's a quick change. But it takes a long time for that magma to build up enough to actually explode. So I'm going to say...
And to mine the obsidian. Obsidian, actually, I only learned this from a game that's like one of the...
Oh, Riley, did I call on you? Okay, thanks. Takes a long time to build to eruption. All right, one more thing that you learned. Emily.
I learned that it takes a while since there's so much layers on the magma.
Okay, so you're saying there's more than one layer of the earth? Because the magma is not right here, right? Or else I couldn't stand on it. Where is the magma?
It can be in Hawaii, it can be in...
But is it right on the ground? Where is it?
It's like... It's the fourth layer in the ground.
Okay, so I'm going to say that magma is deep in the earth.
I still might say magma. I learned that it was the lava is called when it's under.
Jackson, thank you so much for not shouting out while I was writing up what we learned. I appreciate that. Okay, so Riley, now that we have written all the things that we learned, going back to our objective today, it says that we're going to be able to prove that it changes quickly and slowly by doing an experiment. So we've learned a few things about our volcanoes now. I think that we should build one. Now, listen carefully before we build what I'm going to model for you exactly what to do step by step. And we're going to go through this slowly so that we don't make too much of a mess. So you stay where you are right now. Bailey, you stay where you are. Sit down. You are going to have at your desk a plastic cup that looks like this. You're going to have some Play-Doh and you're going to have a bowl, okay? So I already made mine, but notice guys, I didn't have enough Play-Doh to build all the way up over my cup, and that's fine. The most important thing is that your cup is secure. You want it to be staying onto the bowl. So when you get back to your seat, you are going to open your Play-Doh and you're going to take it out, and then you are just going to build some land around the center of your cup. What do you think? Hold on. What do you think this cup is supposed to be? What do you think the cup actually is, Jaron?
I think it's supposed to be like rock and down, like it's supposed to be a rock, and the Play-Doh is supposed to be land, and like we could put something in it into the rock.
I think you had a very great prediction. Let's see, wait a second, which table is going to be able to complete this the cleanest and the quietest and following, wait a second, why are we standing up? While we're doing this, guys, I don't think we need to be talking at all. We're going to keep it on a level 0. If you need help, you need to raise your hand. I'm going to be walking around making sure everybody's using that Play-Doh to build their volcano. You are working independently. Guys, I bought enough Play-Doh and bowls and cups for everybody to use on their own. You don't need to use anything of your partner's today, okay? And then movement, please stay in your seat so that we don't make too much of a mess, okay? It's a lot easier for me to come to you if you need something instead of you get up and then, oh, there goes your Play-Doh, and then it's on the ground, and then it's on the carpet, and then Mr. Mike's mad because he has to clean it up. So let's just stay in our seat. And then you are working independently. If you do all this, you will be successful. Go ahead and get started building your volcano. I will be giving some JoJo behind so you will keep following directions. Oh, table 4 is already at their table following my directions. Thank you, table 4. Table 6, you guys are following my directions. Remember, we're doing this without talking. We don't want our volcano to erupt yet. Go around and record some of it now.
Do we flip it on like this?
No, the cup needs to be facing up. You want the
Like you're going to drink out of it.
yes, exactly. Like you're gonna drink out of it because I'm gonna put some material in there that will act as the magma that turns into the lava.
My sticky.
Perfect. Yep.
Mine won't work. Mine won't maybe because
Oh, I love how table 6 is doing this without talking. Riley, nice job raising your hand when you need help. What is it, buddy?
the Play-Doh's not sticking. Like, see,
You have to spread it out and you have to just kind of push it down so that it makes a thin layer. Yep.
So are we supposed to, well, like you said, put the land around it, so like is put Play-Doh some of the land?
Yes, the Play-Doh is the land. Oh, Jackson's raising his hand when he needs help. What is it?
I just wanted to ask you a question.
Okay.
Can we take these home after?
It's gonna kind of explode probably, so we're not gonna be taking any of it home, okay? You can tell your mom and dad about it, but we can't take the volcano home. Hey Mitchell, why do you have something in your cup? We don't need that in there. Nope. Nope, I'm gonna put something in there. I'm looking for people that have their Play-Doh wrapped around their cup. I might be able to take a picture at the end and send it on JoJo to your parents, yes. Alright, when you are finished, guys, you need to raise your hand because I'm going to be coming around and adding something into your cup. Hold on. Alright, so guys, I'm going to come around to those of you that are finished. And I'm going to put some baking soda inside your volcano. This is going to act as it's going to actually act as the land that is inside. Like, you remember how we saw the 4 different layers of the earth? So the magma is going, or this is going to act as the layers that's already in your volcano. Okay. So we don't have the magma yet. It needs to be all the way stuck to the cup, or to the bowl.
I see how.
Oh, I'm sorry. We're doing science
You are me. I'm trying to get. Yeah, you know that's look at it. Do something. She looks like hold your hands.
When the timer goes off, you need to have your Play-Doh securing your cup.
I can't keep it still.
You have 1 more minute to get your volcano secured.
It breaks this out, and then I'll put on my pineapple and this up.
I'm coming. I'm You don't want to go underneath.
I have a different way to do it. We're going to put it in the center, and then here, this. I accidentally have going like that.
All right. Here's what I want you to do. Ooh, Emily stopped what she was doing and she looked at me. I really love your whole body listening, Emmy. Thank you. You need to put your volcano to the side. And there's a paper in the middle of your desk now that looks like this. It says volcano observation. Guys, real scientists, they do not just do an experiment without writing down what they're doing. You have to take notes and record your observations in order to prove, like we said in our objective, you have to be able to prove that the earth can change quickly or slowly. So, in your cup, I have added baking soda. What do you think will happen? Guys, this is just a prediction. That means it's your educated guess. You are making an educated guess of what you think will happen when the vinegar, I'm going to put some vinegar in your cup. What do you think will happen when the vinegar mixes with the baking soda? I want you to write, it already says, I predict that. So Nicholas, you're going to write, I predict that what? What do you think is going to happen, Nick?
It will do the same thing as Mentos and Diet Coke do. Explode!
Oh, so you've done a similar experiment. I love how he made a connection to a previous experiment that he has done. Steven, what do you predict that's going to happen?
I predict that it will explode when I put the
Good. All right, Audrey, what do you think?
I think it's going to overflow and explode.
It's going to overflow and explode. Good. Hey, Mason, will you go back to your seat? Thank you. All right, so make sure you have that answer written down. I cannot put vinegar in your volcano until my scientists have written down their prediction. Guys, just like a real, good, make sure your name's on that too, Thomas. Just like a real scientist, they also make predictions before they do the experiment. They have an idea of what they think is going to happen. So now that you think it might explode, I guess it is time for us to find out.
I don't think it will explode.
Now, let me go through a couple things. Mitchell, before I give you the vinegar, I want to make sure you guys understand. It might get a little messy. Do you think it's a good idea to scream and throw our volcano in the air?
No!
No.
It would.
When I put the vinegar into your cup, I want your hands to be on your head, okay? I don't want you to be touching it. I want you to just use your eyes, use your ears. Okay, that's what I'm saying. If you just put your hands on your head, you won't get close enough for it to actually explode onto you. Okay? So you are just going to sit back and you're going to observe, because the next question on our observation sheet, Kenneth, says that what actually happened. So you're going to have to observe what actually happened. Guys, so I did put some red food coloring in this to make it act like what? What do you think when it explodes? What do you think it's going to be called, Andrew? Lava. Remember what lava is called when it's in the ground? Magma. Good.
These are green rocks.
Let's stay in our seats. No, it's not something that we're going to eat. Make sure that you're watching, because you are going to need to write down what's happening.
I'm just scared.
Wow, Evil 5 did such a great job following my directions. They all have their hands on their head and they are just watching with their senses.
Don't look.
All right.
put too much vinegar in mine.
It's okay. I did, not you.
Oh! Look at mine, Jesse.
All right, so now that we have put the vinegar in the baking soda, I want you to look at number 2 on your volcano observation. Right? What actually happened, Jesse? We are not touching the volcano. I want you to write down what actually happened. And I'm going to choose some people to share.
It exploded.
It exploded. Good.
That looks so cool. Hey, now look from the eyes.
So awesome. Okay, so Riley, what is all this stuff going to be called now that it's floating around? Can you say it?
Land.
Okay, because why?
Because it is actually making an island because look, it's filling up the whole bottom, so it's technically be making a whole island.
You're exactly right. When it cools off, right? Right.
So, you know what's happening? The Play-Doh is getting this and sucking it in the Play-Doh, and that's what's making it, like mine was up to here, and that's what's making
So the Play-Doh's kind of absorbing some of the lava. That's a really good point. I'm going to talk about that in a
When I move
second.
my cup, it's like the lava is still coming out. When I move the cup, it's like the lava
It's still coming out.
I remember something from the
Focus, focus.
focus.
All right. So Bailey had a good point and Riley had a good point. Riley said, so when all of this lava explodes, guys, it looks like a lot of it has kind of calmed down. It's not overflowing anymore, is it?
No.
So raise your hand if you think you can tell me what exactly is going on right there. If this is a real volcano, Mitchell, what do you think?
It exploded everywhere, then it got calmer and like nothing down.
And what does that become when it cools down like that? Yeah.
Like coal or like rock.
Or like rock, right? And it kind of creates sort of like an island.
It is
and that's
cool.
a lot. It's a lot like how Hawaii formed. And Bailey had another good point that the Play-Doh that's around it kind of absorbs some of that lava, sort of how we saw in the Brain Pop video, how sometimes there's streams of lava coming down. Once it sort of calms down, it's not as explosive, right? Yes. Yeah, sometimes the rocks could turn into like a sandy texture. Yeah. All right, let's look at number 3, Jaron. It says, how is the experiment similar to a real volcano?
It explodes.
I want you to look at your shoulder partner. Say hello. Say, you're the best shoulder partner ever.
You're the best.
And then say, how is this like a real volcano? And now I want you to talk about it. How was it like a real volcano?
The Play-Doh is like sucking it in.
Oh, I love how Thomas is raising his hand when he needs help.
What happens is the Play-Doh is kind of sucking it in. I want to talk. It's like this. I take it out.
Well, it's a little bit different because this actually exploded, right?
Yeah, it's like if I shake, pop up and like.
That's the same thing because the gases are what make it pop out. Okay, well, we're looking at this.
If it's not ruined. Can I get it? I fill this up anyway. I know. Wait, look at that Bro,
Not Mr. Bananas. Jonah, how was this volcano similar to a real volcano?
Oh, it exploded, but it didn't make any land.
Okay, it didn't actually make land, you're right. How else was it similar to a real volcano? Jared.
The magma came out of the top.
The magma came out of the top, just like in a real volcano, right? Something had to ignite it and it got hot enough and it came out of the top and then it flowed out and created the land.
Yeah, and it kind of, since it was cooled down, it kind of went like down to the hill and acted like a rock.
Right, so the Play-Doh kind of helped us see how it flows down, around, and out. Exactly.
Kind of like land.
All right, nice job, Jared. Thanks for answering that for me, buddy. And the last question I have for you guys, was this a fast change or a slow change? Go ahead and write that down. Make sure that you restate. Don't just say one word. You need to say it was a blank change. Go ahead, Jackson. Oh, Jonah has a capital letter at the beginning of his sentence, like always.
Wait, look. Actually, look. What is it that actually
More soda. Yeah. And it absorbed it. Yes, I know what you mean.
And then what I put right here, yes?
How is it? How was it? So you need to explain. It was the same because.
It does not look like red dye. It looks like it's bubble gum ice.
It does kind of look like
I'll tell you about
No, we're not gonna get our. No, we don't need to feel it. Plus, what if it's as hot as the sun? All right, let's find out who knew the answer to that. Was it a fast change or a slow change?
It was actually fast.
It was a fast change, and we learned that in our chart that we made earlier. We already decided a volcano was a quick change. We did. All right.
I wrote both.
Okay, let's explain that, Addison. Why did you put both?
Because sometimes when it is getting ready to explode, it's taking a slow amount of time.
You're right. So if I would have put the baking soda in there last week, it could have technically been a slower change because it was already in there. It just had to wait for the magma to actually ignite, right? Okay, I like your thinking. That's a good point. But for the most part, volcanoes we're going to put under this